In this video, you will learn to identify and label various geometric figures and to know how to graph ordered pairs. Now the terms we're going to cover in this lesson are here on this slide. We have point, line, plane, collinear and non-collinear. We have coordinate plane, x and y axis, origin, quadrants, and ordered pair. So to begin with term number one, we have first a point. Now a point we can describe as being in an exact location in space. A point has no size and is represented by a dot. So an example of this would be the pixels on your computer or television screen. All right, your screen is made up of thousands of pixels, little dots, and each pixel would be considered a point. And this is named with a capital letter. So for example, if we had this picture, we have a point, and then A is the name of that point. We could call that point A, or just call it A. The next term is a line. A line can be described as extending in two directions without ending in a straight path. A line has no thickness, and to represent this with a picture, we would have something like this. So notice that we have a line that goes through the points A and B. And this line keeps going forever in both directions. So a line, don't forget, does go forever. So if you had something like this, where you have a point, and then here a straight segment, and then a point right here, this would not be a line, technically. This would be a line segment, because a line keeps going forever in both directions. Now to name this line with symbols, we could call this line AB or line BA. So we use the two letters that are found, or the 2 points that are found on the line. And then in math notation, we can draw a line symbol above the letters AB or BA. So if we draw a line symbol above it, that indicates that we have a line. Our third term is the term plane. A plane can be described as a flat surface that extends in every direction without ending. So just like a line goes forever in both directions, a plane goes forever in all directions. And a plane has no thickness, and because it keeps going forever in every direction, it also would have no edges. And the way we label a plane is with 3 non-collinear points on the plane. We'll explain the word non-collinear a little more in detail later, but it's the idea of points that are not on the same line. So in everyday life, a plane might be something like a flat surface, so like a tabletop or a floor or a wall. But remember in geometry that a plane would technically go forever in every direction. So a wall would not technically be a plane because a plane in geometry would have to be going forever in every direction, whereas a wall has a definite starting and stopping point. But for everyday purposes, everyday life, we can consider a wall a plane. So to represent a plane with a picture, we can draw it like this. Usually it's a parallelogram where you have kind of like slanted sides that indicates that it's a plane. This kind of gives it a three-dimensional a look to it. But we have 3 points on that surface. So here we have points D, E, and F all on that surface, and notice they're not all in the same line. They're not all in a straight line. And so to represent this, we can call this plane DEF. We just use the 3 letters on the plane, but the order does not matter. We could call it plane EDF or FED or anything like that. So all we need is 3 points on the plane to be able to label or name that plane. Some other terms to know, we have next collinear points. The prefix co right here has the idea of being with, and then the other part, linear, we see the word line in that word, L-I-N-E. So linear means line. So collinear literally means with or on the same line. So if they're collinear points, they are points all with or on the same line. So here we see collinear points A, B, and C. These are all on the same line. Whereas this picture right here, A, B, C, B is not on the same line as A and C, so these would be non-collinear points. Next we have what we call a coordinate plane. So coordinate plane is used in geometry for graphing, and it's also used in algebra as well. And a coordinate plane is simply this surface you see over here on the side where we can graph different things. It's also sometimes called a Cartesian plane. It comes from the guy named Rene Descartes. So you might hear both terms meaning the same thing. Now on this coordinate plane, notice that we have four main parts, four main segments, and we call those different sections of the coordinate plane, we call them quadrants. So here we have quadrant 1, 2, 3, and 4. By the way, the numbering is important. So quadrant 1 starts up here in the top right corner. And then we go counterclockwise this way. So we have quadrant 2, quadrant 3, and quadrant 4 over here in the bottom right. So make sure you know the numbering of the quadrants as well as what that is. Next we have what is called the origin, which is this point right here. Okay, and then we have what's called the axes, which is plural for axis. So an axis is a line. So the x-axis is going to be this line right here. So the one going from left to right is called the x-axis. And then the vertical one going up and down is called your y-axis. So again, the origin would be where those two axes intersect, where they cross over. All right, and in case you're trying to remember which one is x and which one is y, a way that you could remember is that if you take the letter y, so you draw the letter y and then you extend this part of the letter y, notice you have a vertical line. So the y-axis is the one that has the vertical line, the one going up and down. So that's just a way to remember. It doesn't matter how you remember, but do make sure you know which one is which. Now to finish off, we want to know how to graph different ordered pairs on this coordinate plane. Now what is an ordered pair? Well, when you think of the word pair, we think of two items, and that's what we have here. We have a pair of two numbers. So for example, we might have something like 3, 1, and you put it in parentheses. This is an ordered pair because we have a pair of numbers. We have two different numbers put together. This first number in the parentheses is called your x coordinate, and then this second number, the 1, is called your y coordinate. And in case you're forgetting which one is which one is x, which one is y, just think through the English alphabet. Okay, x comes before y in the alphabet. Same thing with an ordered pair. X comes before the y coordinate in the ordered pair. Now what this does is this gives us a specific point or location on the coordinate plane that we can graph. So if you were to graph, for example, the point A, and A is the point 3, 2. Remember, 3 is your x value, 2 is your y value. So when you graph this, you have to think through which way is your x numbers and then which way are your y numbers. So your x-axis, remember, is this horizontal line right here. This is your x-axis. Didn't do a great job with tracing, but you get the idea. So this is your x-axis, and so when it says 3, okay, 3 is a positive 3. When you go to the right for your x-axis, the numbers to the right of the origin are going to be positive. The numbers to the left over here are going to be negative. So when it says 3 for x, you start at the origin right here at this point, and you go 3 in the positive direction. So 3 to the right. 1, 2, 3. So it takes us right here. But we also need to account for the y component. So y is up and down, right? So y-axis would be this vertical line. And for the y-axis, numbers that are up are positive, numbers that are down are negative. So when it gives you a positive 2 for y, that means you go up 2. So we already went over 3, right, for the x part. So from here we go up 2, 1, 2. That's the positive direction for y. That takes us right here to this point. So y, or point A, sorry, would be right here at the point 3, 2. Now we have another point. This is point B, and this is found at 0, 4. Now again, remember, your x value is your first number, and your y value is your second number. So when it says graph 0, 4, we have to go 0 in the x direction. X is left and right. So when it says 0 for x, that means you're not going left or right at all. You're just going to stay right here in the center. And now y is 4. It's a positive 4. And for the y-axis, remember going up is going to be positive. So you go up 4 in the positive direction. 1, 2, 3, 4. That takes you right here at this point. So this would be point B, over 0 and up 4. Now what if you had some negative numbers? Let's say we had point C found at -3, -1. So here both numbers are negative. And the first number is your x value, second number is your y value. So when it says x is -3, that means we're going in the negative direction for x. X is left and right. Negative would be to the left. So when it says -3 for x, we go to the left from the origin, 3. 1, 2, 3. That takes us right here. Okay, but we need to also account for the y component. So I'm just marking here to show you we go over 3. But we also must go down 1 because y is -1. Y is up and down. And negative for the y-axis is going to be down. So you go to the left 3 for x, down 1 for y. That takes you right here to this point. Next, we have point D. Point D is found at 2, -3. So to graph this point, x is 2, y is -3. So if x is 2, that means you go in the positive direction for x, which would be to the right. You go over 2 to the right. So it takes you right here. And then -3 for y. So you have to go in the negative direction for y, which y is up and down. So negative for y would be down. So you go down 3 for y. So you go to the right 2 for x, down 3 for y. That takes you right here to this point. So that would be point D. Now point E is found at 2, 0. So again, your first number is going to be x, second number is y. So if x is 2, that means you have to go 2 to the right in the positive direction for x, so 2 to the right. And then y is 0, which is up and down, so it means you go up and down 0. So you don't go up and down at all. So your point 2, 0 is right here on the x-axis, and we have that graphed. So we have learned different terms, we've learned how to graph ordered pairs, and that concludes our lesson for today.